One of the wonderful aspects about these Project Lead the Way courses is that students are learning new knowledge and gaining understanding of things that actually happen in the real world.
The static determinacy equation is what you use to find out if a bridge, a truss, is stable. So that would be 2 times the joints equals the members plus, let's see, I think it's members plus reaction forces. Yep, members plus reaction forces.
We've allowed our students to be more hands-on with their STEM learning, science, technology, engineering, and mathematics. It's also allowed our students to be able to be more engaged and enjoy the fun aspects of all the different kinds of learning.
What's interesting about the Project Lead the Way approach to education is that it really is project-based learning, but it's also inquiry-based learning because students are looking at bigger questions in the world.
My partner and I spent about a week and a half building this robot from a bunch of different parts. We were told to make it run using a controller. Now what we're doing is trying to program it so it'll move completely on its own using a program called Robot C. And whenever the button at the front is pressed, it'll back up, turn, and keep going.
They're doing projects and learning technological engineering and mathematical skills as part of that process, but they're solving the problems. They're thinking through the process. The teacher gives them a small chunk of instruction, sets the context, gives some basic information.
Okay, so I'm going to put it on the edge, and then you're going to put it right in there.
Okay.
Okay.
The paper and then putting it in there.
In the glue.
And then the students take that with the particular problem of the day that's involved with what they're looking at, whether it's something in robotics, in rocketry, hot air balloons, and the mechanics of that. And then the students build the piece of technology that they're going to be testing, and they test it.
My challenge through this program, the codes were not matching up with the robot. I did not realize on the computer that there were 3 different categories that the wires could be plugged into. So they were not plugged in, and the computer program in the robot did not work.
And they try and make it better. They try and figure out what didn't work. Why didn't it work? How can I make that better? And that's the process of where you take the project and it starts to go into the inquiry level, because the students are questioning, why didn't that work? What can I do? How can we make this better? They ask each other, they ask other resources, they can go out and search that. So it's a hand in hand. I mean, I really do see it as a mix, but at different levels.
What we're doing in this class is we're building airboats, and we have to build them to where we want it, and it's a lot harder than it looks.
In PLTW, Flight in Space, I learned how to make an airplane go into the air with 5 degrees. We also experienced how to make rockets, parachutes, and kites. In my career, aerospace engineering will help me.
In PLTW, Science of Technology, I learned to be very precise in what I was making. It helped me understand more about my career goal in being a doctor.
In Project Lead the Way, we're learning automation and robotics. In here, we learn how to use the program on the computer and build robots. And this will help me in my movie producing career so that I can do certain animations on the computer and also build robots for certain types of movies.
My career goal is being a veterinarian, and this class helps me with mathematics.
When we constructed, we used like shapes, like triangles.
And why would you use triangles?
Triangles are the strongest and most stable shape to use when constructing bridges.
All right, so could you show me what you mean by that?
Like right there would be a good example. How it has 1, 2, 3 triangles.
Yeah, excellent. Okay, and how did your project do?
It did okay, but we could have used some more things. It held 10 pounds.